This is SpaceTime Series 25, Episode 20. Coming up on SpaceTime, Lockheed Martin to build the first rocket to take off from another planet. We count down to the launch of ExoMars. And understanding neutron stars through atomic nuclei. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA has awarded Lockheed Martin the contract to build the first rocket that will take off from another planet. The Mars Ascent vehicle will launch from the red planet's Jezero crater in the early 2030s, carrying the first soil, rock and atmospheric samples back to Earth. Those very same samples are currently being collected by NASA's Perseverance rover as part of its mission to search for signs of ancient microbial life on the red planet. The Mars Sample Return mission will be one of the most complicated ever undertaken. Current plans will call for 2 launches, the first in 2026. It'll include a launch vehicle to get into space from the Kennedy Space Center in Florida, a cruise vehicle to fly to Mars and enter orbit around the red planet, a sample retrieval lander descent vehicle, which will deploy from the cruise vehicle and land on the red planet's surface. There'll then be a sample fetch rover, which will be deployed from the descent vehicle. The rover will be equipped with a robotic arm and a basketball-sized capture, containment and return system that will retrieve the samples collected by the Perseverance rover. The fetch rover will then go back to the landed descent vehicle, where it will place the capture, containment and return system in a small payload bay aboard the Lockheed Martin Mars Ascent vehicle, which will be mounted on the descent vehicle, which will serve as the launch platform. The ascent vehicle will then blast off from Mars, flying back up to orbit, the first launch from another planet. It will then be intercepted by a second spacecraft called the Earth Return Orbiter, which will then collect the capture, containment and return system for the journey back to Earth. Finally, the capture, containment and return system and its samples will be transferred to a sealed biocontainment system in order to prevent any cross-contamination, and will be placed in an Earth entry capsule, which will deliver the samples to the ground on Earth for scientists to study. The Earth Return Orbiter and the rover, which will recover the samples on Mars, are being developed by the European Space Agency.
The planet Mars has been mysterious for centuries. But over the past few decades, a fleet of orbiting and landed spacecraft has greatly advanced our understanding of it. Based on this knowledge, Mars scientists are now ready to take the next big step, bringing Martian samples back to Earth, where the full power of our terrestrial laboratories could be applied to unlocking the story of the red planet's geology, climate, and especially its potential for life, either in the past or even today. But however you tackle it, returning samples from Mars is definitely a complicated problem. So how could we actually get a sample from Mars? One approach is to use a series of 3 spacecraft working together like a relay team to deliver samples to Earth. NASA's Mars rover will acquire a set of carefully selected samples of rocks and surface material and store them in sealed tubes for possible return to Earth.
So we have a drill on the end of our robotic arm, and as we are drilling the surface of Mars, we will be collecting pieces of Mars into the sample tube at that time. We'll then transfer that sample tube into the inside of the rover and then seal it for storage as we continue to explore the surface. After we've collected a diverse set of samples, we will drop them off onto the surface and then have them there for our future sample return mission to continue.
NASA and the European Space Agency are now working together to explore options for a pair of missions that could take the next steps to bring these samples back. In one scenario, after the Mars 2020 rover has placed its collected samples on the Martian surface, a second follow-on mission would land nearby, deploy a small rover to fetch the samples, and bring them back to the lander, where they would be loaded into a container and placed atop a small rocket. The rocket would then lift off, carrying the samples up into Mars orbit. Waiting in orbit would be a third spacecraft, an Earth Return Orbiter, that would find the samples in space, catch up with them, capture the container, and bring it back to Earth.
It is complicated, but fortunately we're not doing it alone. So we have a great partnership with the European Space Agency, and they're providing some major pieces of this mission. Within NASA, we've actually got a number of centers working on all of the different pieces. So we're partnering with Marshall Space Flight Center for the Mars Ascent Vehicle, Langley and Ames for the Earth Entry Vehicle, Glenn for the Sample Fetch Rover wheels, and we're partnering with Goddard for the orbiter payload. And so there's really it's a whole NASA effort to get Mars sample return done.
With Mars samples safely back on Earth, scientists around the world would be able to study them in state-of-the-art laboratories for decades to come. The payoff of a sample return would be a breakthrough in our understanding of the history of Mars and of the potential for life beyond our home planet.
This is Space Time. Still to come. Counting down to the launch of ExoMars. And a new study shows that more power will be needed to make oxygen on Mars and the Moon for future human habitation on these worlds. All that and more still to come on Space Time. This year should finally see the launch of the second part of the joint European Space Agency and the Roscosmos ExoMars mission to the Red Planet. The first part of the program launched back in 2016. It placed the ExoMars Trace Gas Orbiter into Mars orbit and deployed the Schiaparelli Entry, Descent and Landing Demonstrator Module, which was to fly down to the Red Planet's surface, landing in the Meridianum Planum. The orbiter performed just as hoped for and is still providing breakthrough science. But the lander sadly failed to make it, crashing on the surface instead. The second part of the ExoMars program was to launch in 2020, but ongoing technical delays with the scientific packages and travel restrictions brought about by the COVID-19 pandemic have delayed the launch from the Baikonur Cosmodrome until September this year. This part of the mission will include a German-built cruise stage, a Russian lander called Kazachuk or Little Cossack, and the European rover named Rosalind Franklin. The 828-kilogram Kazachuk lander is based on the Schiaparelli module and is slated to land on Mars in Oxia Planum in June next year. The lander is expected to image the landing site, monitor the climate, investigate the atmosphere, analyze the radiation environment, study the distribution of any surface water at the landing site, and perform geophysical investigations of the internal structure of Mars. Mission managers say the lander should operate for at least one Earth year on the Martian surface, with its instruments powered by solar arrays. Meanwhile, the 300-kilogram six-wheeled Rosalind Franklin rover will scout the Martian surface, studying the terrain with its array of scientific instruments and automated onboard laboratory. Rosalind Franklin will use a ramp to descend from the lander onto the surface. But that poses its own problems, as this report from ECTV's Najida Vicenti explains.
What will happen is that the rover will land encapsulated in the platform. Then it will unfold the wheels and the ramps will be deployed. This is a very delicate and potentially dangerous operation.
This is a dedicated facility to perform egress tests. Actually, what we're testing in this period is different configurations of slope and orientations of the lander and the rover. We want to account for any adverse situation. For example, landing on the foot of a small hill, which have our lander tilted. Or landing when our ramps open, we have an obstacle on one of them, or one of another ramp lands on an obstacle, so you have to egress in a tilted configuration.
Now the test platform is tilted 5 degrees. We are simulating what the rover might encounter when it lands.
It's no, yeah. I mean, can we go? We never did it, but.
We are increasing the level of difficulty of this test. Before, we went for 5 degrees. Now we are moving up to 15 degrees. If before I was nervous, now it's even worse.
Well done! The rover has to overcome actually obstacles which are have a height of at least 250 millimeters. There are pyramidicals, round or square ones, and we will test to overcome one or several in different inclinations.
Without deployment actuators being strong enough, we can implement an additional locomotion mode, which we call wheel walking, which articulates a motion around This axis and this motion gives very good traction capability in very soft soils and in very high slopes.
Eventually we will be able to go to places to find interesting elements on the surface of Mars and basically achieving the intended operations and the return in terms of science. We are on track for Mars. We plan to complete this test basically as planned with some minor glitches here and there, then continue with further more elaborated tests.
Many other tests are taking place across Europe to get the rover ready for Mars. While the flight model takes shape, science instruments are carefully installed and the software runs all possible scenarios to guarantee a good performance on the red planet.
And in that report from ECTV's Najida Vicenti, we heard from ExoMars rover engineer Pantela Palakis from ESA, locomotion verification system engineer Boris Holter from RUAG, and locomotion verification model architect Jesus Quis Garcia from Airbus. This is Space Time. Still to come, a new study has found that more power will be needed to make oxygen on the Moon and Mars for future human off-world bases, and understanding neutron stars through their atomic nuclei. All that and more still to come on Space Time. A new study has found that splitting water in its constituent hydrogen and oxygen components using electricity would produce less oxygen on the Moon and Mars compared to the same process on Earth. The findings, reported in the journal Nature Communications, are based on analysis of gas bubbles formed in electrochemistry experiments during parabolic flights which simulate microgravity conditions. The study's authors found that 11% less oxygen was produced with gravity levels representing those on the Moon and Mars compared to what was produced under Earth-like conditions. The researchers say that splitting water in this way is how humans on the Moon or Mars could produce hydrogen gas for fuel and oxygen gas for breathable air and as an oxidizer. The findings suggest that potential future human off-world settlements on the Moon and Mars will need to consider much higher energy demands in order to produce these resources. This is Space Time. Still to come, understanding neutron stars through atomic nuclei, and later in the science report, a new, more highly virulent version of HIV discovered spreading through the Netherlands. All that and more still to come on Space Time. Scientists are using lead atoms to try to better understand the composition of neutron stars, the densest objects in the universe other than black holes. Neutron stars are created out of the death of stars at least 8 times more massive than the Sun in what are known as core collapse supernova explosions. As they collapse, the immense mass of these stars causes their cores to crush down so intensely and with so much force that the electrons in their atoms are literally driven into the protons in their nucleus, creating neutrons. The result is an object with more mass than our Sun, crushed down inside a body only a few dozen kilometers across. Just a teaspoon of neutron star material would weigh billions of tons, and that makes them a cosmic extreme worth studying. But much of what we know about neutron stars remains a mystery. For example, scientists know very little about the internal structure of these enigmatic stellar objects. One way to get around the problem may be by studying neutrons on the subatomic scale, as a way to better understand the structure of neutron stars on the stellar scale. Atomic nuclei larger than hydrogen are usually composed of protons and neutrons, with typically close to equal numbers of each. But as nuclei get heavier and heavier, they need to pack in more neutrons compared to protons in order to remain intact. And these extra neutrons tend to stick to the outer edges of heavy nuclei, where they form a kind of neutron-rich skin around a more evenly distributed core. And this is where physicists with the Lead Radius Experiment collaboration come in. They've been using the United States Department of Energy's Continuous Electron Beam Accelerator facility to study the neutron-rich skin in lead nuclei. To do this, researchers send a precise beam of electrons into a thin sheet of cold lead. These electrons are spinning in their direction of motion, like the spiral in a gridiron football pass. But what the physicists have done is flip the electron beam spin from one direction to its opposite some 240 times a second throughout the experiment. Now, the electrons mostly interact with the large protons through the electromagnetic force. However, there is also a subtle change induced by the weak nuclear force, causing electrons that interact through the weak force to preferentially interact with neutrons. What makes the weak nuclear force unique among the four fundamental forces is that it's not mirror symmetric. And in this experiment, the broken symmetry meant the electrons spinning in a preferred direction scattered more often. And exploiting this difference allowed the physicists to undertake the most direct observations yet of this neutron-rich skin. They were able to measure the neutron-rich skin of the lead nuclei, finding it had a thickness of 0.28 femtometers. The results, reported in the journal Physical Review Letters, are thicker than some theories had suggested and indicate that the internal density of the lead nuclei must be lower than expected. However, the internal pressure that neutrons in lead experience is higher than scientists once thought. These results have implications for science's understanding of the physical processes in neutron stars and how they would interact as two neutron stars collide and merge together, a process already witnessed by gravitational wave observatories, resulting in the creation of a black hole. This is Space-Time. And that's the show for now. Space-Time is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. Space-Time's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Space-Time store for a range of promotional merchandising goodies, or by becoming a Space-Time patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Space-Time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Space-Time YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary. And Space-Time is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Space-Time with Stuart Gary. This has been another quality podcast production from Bytes.com.